Welcome to this mix for the ODU unit on equations of motion. What you need to know from this area is you need to be able to identify the three equations of motion. They're given on the data sheet and you need to be able to apply them to solve problems. And all these problems have a constant acceleration. There are three equations of motion. You need to be able to use these. I'm going to show you in the next couple of slides here where they come from, but you don't need to be able to do that bit. You just need to be able to apply them at the end. So this is kind of for interest, but nothing else. So the first one is just a rearrangement of the acceleration formula. The acceleration is change in velocity divided by time, and it's just stated in terms of the final speed v equals to the initial speed u plus a times t. The second equation of motion starts with a velocity time graph. Now, as we'll already know from National 5 physics, then we can work out the displacement of an object from the area underneath a velocity time graph. And this approach for the second equation of motion uses this fact, that you're basically working at the areas. So if you look at the graph above there, you've got the one area, which is u times t, is this bit here, and you've got the other area, which is v minus u times t. The difference in the two numbers on the axis times whatever the time is for that bit, times a half. So we get those two areas together, the u times t plus the half v minus u times t, and then if we replace v minus u with at, we end up with s equals ut plus half at squared, which is what's going to come on the next part. And the final third equation of motion links together velocity and displacement. This is the one relationship that doesn't have time in it. And it comes bound by starting with the first equation, u plus at, squaring it, multiplying out the terms, and then taking out a factor. And this factor happens to be equal to s, to end up with v squared is u squared plus 2as. Like I say, you only have to be able to use these three relationships. V equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. The last one being the one without the time requirement. So here are all the quantities. S for displacement, u is the initial velocity, v is the final velocity, a is acceleration, t is time. These are often sometimes called SUVAT questions because those are the 5 terms that you need to know. So when you're answering the questions, you should always write out SUVAT and then list the quantities that you've got, because that will help you pick the right formula to use, as we'll see in a moment. Data is not always given, but can be implied. So if you're dropping an object, the initial velocity is going to be 0 because it's dropped. Whereas if it's thrown, it won't have a 0 initial velocity. If its final velocity is going to stationary or at rest, then final velocity could be 0. If you're throwing up an object, then when it gets to the top, so here's my ball going up, when it gets to the top, it has a velocity of 0. So we can use that maximum height to work out there. And if we're in constant acceleration looking at vertical objects, then acceleration is 9.8 meters per second squared. So write your SUVAT. You don't have to write all the terms afterwards. So here's an example. Car accelerates from rest to velocity of 10 meters per second in a time of 4 seconds. What is his acceleration? So SUVAT down the side there, from rest, so that's coming from here, that's our u, that's our final velocity v, and then we've got our time t. and we have to work out A. So we can see, looking at that the equation of motion, because we've not got S in, is going to be the first one. What you always want to do here is write the formula and substitute in the numbers. Okay, don't rearrange the formula, because your marks come from 1 for the formula, 1 for the substitution, 1 for the answer plus the unit. If you rearrange the formula and get it incorrect, then you will get at the most 1 mark rather than 2. Or if you just write the incorrect rearrangement, you get no marks at all. Second example. A cyclist accelerates at 0.5 meters per second squared for 20 seconds to reach a final velocity of 12 meters per second. So what is the initial velocity? So suvat down the side. S, don't know displacement, it's not mentioned. U, that's question mark, that's what we need to find out. V, our final velocity, acceleration and time given. V equals U plus AT again. Substitute in our numbers. Take care with the brackets. Make sure you put a bracket around A times T. Otherwise what you'll find is your rearranging will start to go wrong at some point. And that gives us U of 2 meters per second. Example 3. An object travels at 10 meters per second. It decelerates at 3 meters per second squared for 3 seconds. Calculate its displacement. So displacement this time is what we need to know. We have an initial velocity, we don't have a final velocity, and we have an acceleration, but we need to know that it says decelerates. So that's why we've got the minus there. Oh, that wasn't what I wanted to do. I wanted to highlight. How do I do that? Like that? No. Poof. So we've got a minus number there. There we go. We'll just do it like that. So we've got minus 3 as our answer, and it's really important we put that in. If we put plus 3 in, we will get the wrong answer. So we substitute in our terms using brackets. Also really important. And then we get our answer plus the unit at the end there. Okay, even though we know displacement and acceleration and velocity are vectors, we usually don't need to worry about the direction. It would just be forwards. Unless it particularly tells us to look at that too. Car accelerates from rest for 5 seconds and has a displacement of 50 meters. Calculate its acceleration. So suvat, 50 meters. Initial velocity, that's rest, so that's 0. Final velocity, don't know. Acceleration, don't know. That's what I need to work out. Time, 5 seconds. So you look at the formulas. Often you need to write them down to be able to pick it, to see what you've got. Okay, so we're going to go with a third one. S equals ut plus half at squared. We substitute in the numbers and we get our answer plus unit at the end. Car accelerates at 2 meters per second squared from an initial velocity of 4 meters per second and has a displacement of 12 meters. Calculate the velocity of the car. So that should be the final velocity of the car. So suvat again, 12 meters, 4 meters per second. Acceleration is 2. We've not got the time, so we need to use the relationship without the time to get our answer. Last example, motorbike accelerates from rest at 3 meters per second squared, reaching a final velocity of 12 meters per second. Calculate the displacement. Suvat again. S we need to find out from rest, so that's U equals 0. Final velocity is 12. Acceleration is positive, 3 meters per second squared. Don't have the time. So we know which formula to use, the one without it. When you're doing your problems, you need to write all the formulas so you can see them on the page and then pick ahead of the body of work that you're looking at. So what do you need to know? You need to be able to identify where the three equations of motion are on your data sheet. You need to know they only apply when we've got constant acceleration. You need to know how to lay out the problems, so write SUVAT, write your three equations, and you need to be able to solve using the problems.